in the Needham Equity Research Department. Following presentation is going to be a fireside. It'll be a fireside with Velo3D, a rapidly growing supplier of metals additive manufacturing equipment. We are pleased to have with us today Benny Buehler, the founder and CEO, and CFO Bill McComb. The company is currently in the scale-up phase with a rapidly expanding backlog, some high-profile customers that include SpaceX, Raytheon, Honeywell. So with that brief introduction, Benny, why don't we start by just telling us a little bit about your background, when you founded Velo, the approach you're taking to the metals additive manufacturing market, which is a little bit different than some folks, and then we'll go a little further into the story. But welcome, both of you.
Thank you so much. I'm really excited to be here. So I'm a physicist, grew up in Israel, and spent the first 10 years of my career in the technology unit of the Israeli intelligence. We used to make Mission Impossible projects for very high-value targets. On one of those projects, I got the National Security Award from the President of Israel when I was 29. I moved to the United States, worked in semiconductor for quite a few years, as well as in solar technology, photovoltaic and solar. I founded the company in 2014, and the impetus for founding the company was I was an investor for 2 years, and we invested in a company that was building engines, and they were building rocket engines using 3D printing. And the reason why they started to use 3D printing is because they were trying to make geometries that would be very difficult to produce in conventional ways. And what shocked me is that every part that they were making took them about 3 months to make, even though they could hold the parts in their hand. And the reason for that was because none of the parts that they were designing were manufacturable. And this is a very smart group of people, very smart company, very innovative company, but none of the parts that they were designing was manufacturable by additive manufacturing, which was the reason why they went to additive manufacturing to begin with. So I started to talk with other people that were using the technology, and I found that this was a universal problem. Basically, exclusively, all the parts people wanted to make were non-manufacturable, and then people had to redesign those parts and massage them and compromise them until they could get at last something that was kind of manufacturable and kind of what they could use. When I realized that, I decided, I asked the question, what would be the value of a solution that we could overcome this manufacturability limitations? And the feedback I get from all the users I interviewed at the time was, this would be the most valuable thing in additive manufacturing since it was invented. And then they took a break and they said, but don't worry about it, it's completely impossible. So very high value and completely impossible. It was a deja vu moment for me, kind of reminded me my youth in the intelligence. I said, I'm in.
Great. Tell us a little bit more, though, about the technology that Velo has developed. As some of the way you describe it is full stack production ready additive manufacturing for metals. Help the audience understand what that means.
Yeah, sure. So at the heart of what we do is our Flow print preparation software. Flow is a computer-aided manufacturing software. It's not a design software. It's a software that takes the production, the file, the design file, and translate that to production instructions. And this is an extremely sophisticated software powered by artificial intelligence that is doing about 100 times more processing and more calculations than a conventional print preparation software does. And what it does is it analyzes the object and it breaks it apart, and it identifies a few tens of different geometrical types that each one of them requires a completely different manufacturing process to be able to produce it. And then it assigns for each one of them the right manufacturing recipe from a very large library of manufacturing recipes that we developed. And then our printer executes those recipes. And then our quality assurance software, Sure, is validating the quality of those recipes and keeping the printer calibrated at all times to be able to execute them. So when we started this company, we had a very clear North Star. We are going to make the parts people really need at the quality that they need without compromise. And that's what we decided to do. We didn't know what it will take to do that. And we kind of learned what it will take to do that gradually and build this software as the solution, the core of the solution, and the architecture of the Sapphire system and the Assure calibration are basically all elements of the solution that were needed to be able to execute these very sophisticated recipes that we developed.
So the software is an absolutely critical component of the overall solution that you're providing. You know, when I look at the background of some members of the management team, yourself included, several of you come out of the semiconductor capital equipment industry, which I know our listeners know has had a long, very established reputation for developing equipment that really focuses on process control, process development. And, you know, for folks who have been looking at additive manufacturing, the industry over the years, I guess, candidly, that some of that discipline's been lacking, you know, and to what extent is Velo bringing more of a semi-cap mindset to the market?
Yeah. You touch upon a really important point, right? We are in Silicon Valley and not by coincidence. So we have a very deep semiconductor heritage that is manifested in many places in the product. So this first concept that I described to you, the idea that you have a library of processes for different devices that are optimized as the solution to be able to create different devices, this is really stolen from semiconductor. The next thing is that if you look at the manufacturing process of semiconductor, it involves hundreds of layers with trillions of points that needs to be produced perfectly in every layer. And that's not very different from additive manufacturing. If you look at how semiconductor is handling that, they are not controlling the quality at the end of the line. The quality is controlled in every step of the line, and the quality is controlled in situ while you're making it to make sure that every step is done perfectly. And that's exactly how Sapphire works. So the reason why we invented Assure and the reason why we put all these very unique metrologies within Sapphire is because we use that to maintain perfect calibration of the equipment. So the equipment in every layer is for sure making the best process, perfectly calibrated exactly in the center. So there is a very big concept in semiconductor called copy exact, meaning all the equipment that you have to be exactly identical, have to get to exactly the same outcomes. And all our systems are operating always from exactly the same recipe with exactly the same outcomes. This is, again, the concept that we took from semiconductors. So we see additive manufacturing as a technology at the level of sophistication that you find in semiconductor, and it has to be treated with the same gravitas and seriousness that you treat quality control in semiconductor.
Yeah, that's a really, I think, important point. You know, one of the other points the company talks about, as you describe the technology, is being able to produce these very complex parts, but essentially in more of a support-free environment. And I think folks understand that, but maybe you should expand on why that's so important, because I think it also gets back to some of the earlier comments you made about the frustration people have had over the years with the technology.
Right. So let's see if this will work. So this part that I'm holding in my hand is a micro gas turbine. And this is a role model of the parts that you would want to make with 3D printing, with additive manufacturing. It has about 5 internal cavities. It's a full engine made in one part. And historically, you would need about 60 parts to produce this. And the trick about this part, it's so small that you actually can't assemble that from a distinct 60 parts. So if you could make it, additive manufacturing would be the only way for you to make it. The problem is that when you open this inside, and you can see that on the presentation that I shared that we have on our investor relationship, but when you look in this inside, you'll see the whole thing is full of internal cavities. Of course, you don't have access to those internal cavities, and those internal cavities are full of supports in conventional additive manufacturing. And the problem with those supports is that when you finish the build, you created a very expensive piece of garbage. Because there is no real way to get there. The whole reason why you start with additive manufacturing here is because you don't have access to make it from the inside. So you have all this support inside, and you have no way to remove them. You have no way to clean after them. So this is really not the practical way to make this part. With us, we just make this part as is with no supports inside, and the part is basically ready for its next step in making it a full engine. And this part is not unique. This part is the role model of what you would want to do additive manufacturing for. And this is the type of innovation that we are enabling and the type of parts that we are helping people to make. And the confusion that people have is that these parts are not some niche application of additive manufacturing. This is the reason why people want to go to additive manufacturing to begin with.
Right. Benny, you touched on this earlier when you were talking about the software Flow, Assure. How much of a technology differentiator is this for you in the market? It sounds like it's critical.
Yeah, so the technology here is massive. So it took us about $150 million and 6 years to build this. And it's important to say that there's practically every STEM profession except biology that is working under our roof. So we built a very interdisciplinary team, and you can hire as many interdisciplinary professionals as you want. The challenge is to manage them as one cohesive unit to get to cohesive outcomes. And it's really difficult to build something like that. The fact of the matter was that a lot of people thought it is impossible when we started. And we created this massive patent portfolio that is a very significant moat to prevent from others to move after us into this. And just to explain a little bit about this IP protection, we protect this IP in 3 layers. The first layer is the system innovations that you find in our solution. They are protected, so people cannot just copy them because we have a very broad coverage for this system innovation. So this will prevent for competitors to just copy us and sell those systems. But if they did sell those systems, their customers that would be using those systems would infringe on our recipes that we invented and that we patented as well. So now, if a competitor is infringing on our IP and sell a system like that, not only they are at risk, but they are risking their customer. But we didn't end there. The parts that would be produced on those systems carry a signature of the process that we invented, that we patented as well. So now the people that are trading at that are at risk as well. So someone may sell $1 million system and create, by doing so, $100 million liability for themselves. So the multi-layered and very thorough and very broad IP protection that we put is going to make sure that we keep this differentiation for many years.
Thank you for that. I want to focus on one of your bigger customers, SpaceX. Mm-hmm. And incidentally, an early investor in Velo. Clearly, they have a reputation as being a pretty demanding customer. Tell us about how the relationship with SpaceX developed and where it stands today.
Yeah. So I want just to correct one thing that you said. SpaceX is an early customer, but they are not an early investor.
I'm sorry, I thought they were.
No, they became an investor relatively recently, about a year ago. They became a customer.
No, thanks for clarifying that.
And I'll explain the context of that. So the relationship with SpaceX started before there was a company. Like with many other customers, this was when I started to evaluate, does it make sense? Who needs this thing? And SpaceX were one of the people that told me this would be huge, but don't worry about that. This is impossible. And as we made progress, we showed that to SpaceX, and they were gradually more and more impressed about us actually being able to deliver on our dream. SpaceX was a beta customer, and one of the reasons why they went into that is because they had a number of parts that they were compromising in a very significant way with their existing additive manufacturing technology. And this is not unique to SpaceX. Other people have been in the same situation. Most of our customers, when they start with us, that's because there is a specific part where there is a very big compromise. When we were able to make those parts without the compromises that were taken in the commodity or legacy additive manufacturing techniques, they saw, why don't we start making those improvements in other parts that we already produce? And we have gotten used to compromise with the commodity additive manufacturing. So they started to move another part and another part and another part into our system. And by now, they have tens of parts in the Raptor engine and the Starship that are relying on our manufacturing system and on the systems that they have. They have a massive amount of systems there. The way they became an investor is through they wanted to migrate their entire Raptor additive manufacturing production to Velo3D. They couldn't do it because we didn't have big enough systems. So for a very long time, SpaceX wanted us to make a bigger system so that they can take advantage of our capabilities also at larger scale. And we didn't have the money to do that. So the investment was part of helping us to accomplish that. I want to mention that we would not have been here without SpaceX. SpaceX pushed us. SpaceX is the Intel of semiconductor in aerospace. They are fast, they are aggressive, they are ahead of everyone, and they are ruthless in their demands, but they will make you a great supplier if you survive this effort.
Yeah, that's very helpful. I think that tells us a lot. I wonder if you could talk a little bit about other customers. And yeah, I think one of the things people try to gauge is how many of these customers are now deploying multiple machines. Obviously, it's a sign of real commitment and progress.
Yeah, so we have a very fast growth in the number of customers, but we communicated in the PI presentation, in the presentation that we shared, that that 5 customers ordered systems. This was true to the end of January when we published that. Since then, more customers bought repeat orders. In general, you asked about other customers. We for every customer like SpaceX that wants to build their own parts, there are about probably 10 customers, OEMs, that want to buy parts. One of the most important things that we have been doing is building a very robust supply chain of contract manufacturers that can supply many of those customers. And those suppliers like Closed Godwin and Duncan Machine Products and Wagner and Primus, they are really strategically positioned to supply people from the aerospace industry, both aviation, commercial and defense, space, oil and gas, power generation. So we partner with contract manufacturers in this space to be able to serve all these customers. And many of the customers that we serve, the OEMs that we serve through those contract manufacturers. So for example, Raytheon, Siemens, Schlumberger, those are customers that are served through those relationships.
And those contract manufacturers are fairly sophisticated, so when they make a commitment to the technology, they understand it pretty well. I guess it's also fair to say.
It's actually really important, right? So we tend to partner, not exclusively, but tend to partner with companies that are really strong suppliers in their industries, in machining typically, and we help them come on up to speed on the art of additive manufacturing. So part of the solution of a turnkey solution where we provide the full technology stack for operating that is it makes it very easy for a machining supplier to add that as a technology to their platform.
Talk a little bit about, to the extent you can, the technology roadmap at the company.
Sure. The extent I can. The overarching principle is taken from semiconductor in its philosophy, is you start with capability, then you focus on quality, then you focus on cost. Every new product has these 3 stages: capability, then quality, then cost, by this order. So on one hand, we are always pushing the capability to allow our customers to do more, to push the envelope of the geometries that they can invent. And this is done through our continuous innovation on process technology and on our software that I mentioned. As a part of that, we also introduce new materials all the time. We already have about 10 materials. More than half of them were introduced in the last 12 months. And we're probably going to introduce a similar number of materials this year. So that's kind of on the capability side. In addition, we are constantly pushing the quality part. And what I mean by pushing the quality is reducing the defectivity in the parts and improving the ability to detect defects when they happen. Both those things are very important drivers that we keep pushing on the technology side. And then the cost side is a lot of people think about additive and they are really locked up with this cost equation. But people have to understand that when you are developing a new product or when you are taking an existing product and you transition that to additive, there are really two important steps in the process. There is the development and qualification step, and there is the ramp up of production and the scale up of production. And cost is really material in the scale up stage. In the development stage, cost is not that important. It's important, but much less. Speed, quality, consistency is much more important in the first stage. All those things plus cost is important in the second stage. So in that context, we developed the Sapphire XC system. And the Sapphire XC is not a new platform. It's a Sapphire system that the term XC means extra capacity. It's a scale-up solution. And it's built in such a way that you can take the parts that you developed on Sapphire and then produce them on Sapphire XC with exactly the same software, with exactly the same recipes, with exactly the same manufacturing process, with exactly the same outcomes. So the idea here, you develop on Sapphire, and then when you scale up, you go to Sapphire XC. This is the large-scale system. And instead of buying 4 Sapphires, you buy 1 Sapphire XC, and you have about 3 times lower manufacturing cost than you would have on Sapphire.
Got it. So we touched on the software and materials as well, where there's development underway, and that the number of materials is going to increase. What can you say about the recurring revenue opportunity? Whether it's per machine, how do people think about that?
Yeah, we have 2 main models that we have been selling. The first model is a relatively simple transaction of sale and service. And with this model, over the lifetime of the machine, about 30% of the revenue of the machine will become from recurring revenue. The second model is a model which is really very recurring revenue focused. And in this model, we sell the machine at a much lower price. We sell the service at a much lower price, but we charge the customer royalties for every hour the machine is operating. And the first model that I described, the simpler transaction sale model, is a model that is optimized for OEMs. The second model is a model that is optimized to contract manufacturer supply chain because they don't have 100% visibility to the demand, and they make money when they sell hours on the machine. So if you charge them by the hour, you basically make their cost OPEX and even variable OPEX, not just OPEX. So it's a much more palatable model for them. At the end, over the lifetime of the machine, they will pay more, but there is much less exposure, and the IRR is significantly better on this.
Interesting. In terms of the way you're going to market, I guess historically, at least until recently, has it been more direct? Are you beginning to build out some partnerships, indirect channels?
I'm glad that you asked this question. Our sales model is direct as it goes. So we are selling in a direct sales model in the United States, and we are now building massively the sales team in Europe, and we're basically going to replicate in Europe what we have done in the United States. How are we working with channel? Right. So in Asia Pacific, we partnered with a number of suppliers, of distributors. Each one of them specialized in specific geography, and each one of them an extremely established company in their geography with very good reputation and very good technical capabilities. And we bring these companies to become practically an extension of Velo3D in their geography. So we invest a lot in educating them, in educating their salespeople, educating their application engineers, their service people, to the point that we feel that they can provide to the end customers the experience as if we did that ourselves. So we really don't treat them as a distributor. We treat them as an arm of Velo3D that is operating in this geographies. They would buy a machine. They did buy a machine, and they operate a demo center, and they have the full capability as if there was a Velo3D Japan or Velo3D Korea but they are their own companies, and they are an exclusive partner that we operate in those geographies. So in geographies where it would be very difficult for us to set up a credible distribution arm that is internal to the company, we partner with a high capability distributor that we treat as a partner. The other way that we partner with customers, with distributors, is, for example, in the United States. We partner with GoEngineer in the United States, and the strategic reason for that is GoEngineer is the largest distributor in the world of a CAD software. They are the largest distributor of SolidWorks. And they have tens of thousands of very advanced users that they could bring the gospel to on how your application can benefit from a superior manufacturing technology. And they will sell some systems on their own, but they will also create a lot of indirect demand, right, that is very valuable. So for us, we would never be able to create this capability internally. And they have an expertise that we would never be able to replicate. So that's a very good partnership, and it's a great value for their customers as well.
Yeah, it sounds like a good marketing channel just to really supplement what you're doing internally.
Exactly.
Yeah. Okay. Let's turn to the financials. Revenues in 2020 fairly modest, which certainly not surprising given where the company is at this stage of its development. But sounds like the backlog though has increased quite a bit. And I'm wondering how do we think about the business scaling over the next 1, 2, 3 years?
Yeah. So we had just under $20 million revenue in 2020, and we are planning to do just under $100 million revenue next year. And the question is, how do I explain that? And how do I explain that in a way that you all understand this is not a pipe dream? And the reason is we have a backlog of sales for 2022 from orders and pre-orders of Sapphire XC systems that as of January 31st, when we published the pipe presentation, when we locked the pipe presentation, stood at $47.5 million. We are going to update these numbers soon, and we'll shock everyone with how much bigger this pipeline is now. It is not pipeline, this backlog is now. So there is a tremendous demand for this system. There is a very high visibility into this orders into 2022. And in addition to that, there is a very significant component of recurring revenue from systems that we already sold by now that will feed 2022 revenue. So between the Sapphire XC reservations and the orders, and between the recurring revenue for existing systems in the field, the vast majority of the revenue for 2022 is already called for. Mm-hmm. So we actually have a very low uncertainty about the 2022 numbers, and we are starting to work now on the 2023 numbers. And the jump from 2022 to 2023 is much more modest when you look at our financials. It's a big jump as well, but it's much more modest. And the way we prepare for that is we understand our sales cycle by now really well. We understand the productivity of a single salesperson. We understand how many leads we need to have at the beginning of the funnel in order to get a specific outcome at the end of the funnel. And we start to increase the marketing capacity and the sales capacity now in order to prepare for the sales in 2023 and to build all this demand for 2023.
Good. How would you anticipate the margin profile of the business developing? You're clearly in a very steep investment mode in terms of bringing on additional resources, whether it's R&D, sales, and marketing.
Yeah. So when you look at our simple sale model, the gross margin, the unit economics gross margin for the product itself is just over 50%, and the unit economics for the service is improving, and it will become 50% this year. So when we started, the service component was not as good because those are new systems. There's a lot of issues. We are still learning how to handle them, and there's no economy of scale in our service organization. All those are improving, and as they are improving, we are reaching 50% gross margin on the service. We already have 50% gross margin on the product side. When we look at our recurring revenue model, in the recurring revenue model, the profitability relies on use, on utilization. And the utilization of our system in our contract manufacturing is steadily improving, is steadily growing. And the best indicator of that is when systems are reaching about 50% utilization, the customers are buying more systems. So the fact that we are seeing customers buying more and more systems, we now know that it takes them about 8 to 9 months to get to 50% utilization. So as existing system will have higher utilization, our gross margin for the systems that are operating in recurring revenue mode will even exceed 50%. I want to mention that this 50% roughly gross margin is not something that we want to improve in the near term and to make it higher than 50%. If we will be able to reduce costs, which I have every reason to believe that we will, we didn't model that, but we didn't take this assumption in the model, but we definitely will reduce costs. This will not manifest in better margins, but in lower cost to our customers. And the reason for that is we see a clear elasticity in the market, in the applications, and we want to drive the growth of the market. So we want to have high margin, but not extremely rich margin, so that we want to keep driving the market expansion.
Well, those are already pretty attractive, the margins, just on what you described. So how much has the company raised since its inception?
As of January, when we locked the presentation, $150 million.
Okay. And just as we think about, the additional resources you're going to have, can you give us a sense as to where that's going to be deployed? And for some companies in this situation, there's also an M&A component. But I'm curious, is there any technology bolt-on type things that you feel would be important to add?
Yeah. The expansion that we are going to have is extremely focused, first and foremost, on commercial. So I mentioned to you how we have to scale our sales, marketing, and technical sales team, and this is the first priority. Similarly, we are going to invest more in R&D. The R&D is going to grow more, but not nearly as much as our sales and marketing. And we are executing some very ambitious programs, and these programs will benefit with more people. We didn't talk about the product roadmap beyond the Sapphire XC, but we have some nice rabbits in the hat that we're going to pull over the next few years. So we'll be working on those too. One thing that is really important is one of the reasons why we want this level of investment and becoming a public company is we are a strategic supplier to many of our customers. Our customers, if you think about what we offer them, is we tell them you can rely on a new manufacturing technology to do things you couldn't do before. You are going to commit your new product to something that is not possible to do in any other way. They want to know that there is a reliable supplier behind that is not going to go bankrupt tomorrow. So having a very fat and transparent balance sheet as a public company is really critical for them to feel comfortable with it. So we definitely want to have this big balance sheet as a token of stability for our customers. When you talk about M&A, I have a very different view than some of the other companies that went to market recently on how we want to do M&A and how we perceive ourselves. We perceive ourselves first and foremost as a company that is helping its customers to make high-value parts for high-value applications, a company that helps customers to make their most challenging parts. We are not viewing ourselves first and foremost as a 3D printing company. And as such, we are not trying to become the big 3D printing supermarket that you go for any of your 3D printing needs. We are focusing on very specific segments of the market where I think additive manufacturing is a really great solution. So in this context, we would be willing to acquire companies that have a complementary solution that can solve other problems of our customers really well, of the same customers, other problems, so that when our salespeople go there, they can offer a more complete solution. There is great synergy there. So it's about synergy to the customer, not about synergy on the technology side. So that's how we think about M&A.
Great. I think we've run out of time. But thank you. This has been very helpful. Thank you both.
Thank you.